right, so we've learned, right now, we've learned graphing and tables to solve quadratic equations. And I know today's video is supposed to be specifically over using factoring, but I want to go ahead and just briefly review how we do graphing and when we do graphing. Okay, so we're going to use graphing when the graph and or table of the solution easily shows us integer values. So when we look at it, it's really obvious what the solution is that we're looking for. We're also going to use it if we have a graphing calculator handy and we can find those values easily in the table. So let's take a look and let's work through these really quickly. So when I look at this, sorry, we're going to graph these points. I'm going to tell you right now, I've already gone in and I found the values. I have -5, 0, -4, -5, -3, -8, -2, -9, -1, -8, 0, -5, and 1, 0. I put them like this because I wanted the vertex in the middle of the table, because that kind of allows me to see right away where my vertex is. And remember, we always build out from the vertex when we do a quadratic, so that's the reason why we're doing it this way. All right, now I'm also going to immediately identify my zeros. There's one of them. There's the other. We call them zeros because their last name is 0. And then I'm also going to go ahead and, if I can, identify my y-intercept. Okay, it's good, useful information, and I want to know what it is. Okay, so first of all, I'm just going to go ahead and jot down my zeros. I think they spell it Z-E-R-O-S. I keep spelling it wrong, so I'm going to spell it like that. Z-E-R-O-S. My zeros are -5, 0, and 1, 0. And that's a comma in between there. Okay? And we're going to go ahead and graph it and take a look at it. Let me really quick adjust the focus and see if I can make it a little bit more clear. That's a little bit better. Okay, so we're going to plot these points. I have 1 at -5, that's -6, -5, 0, 1 at -4, -5, yep, 1 at -3, -8, -2, -9, and there's my parabola. We don't just plot the points. We want to draw the parabola because, remember, we want to be able to see what the shape of this parabola means. Okay? This one has two solutions because I can see that when f of x is 0, so when 0, which is my x-axis, when I cross my x-axis, it goes through the value at two places. Now, it doesn't matter what the value is, okay? But when I have two solutions, it's going to cross in two places, all right? So I might have it's below the solution, well, the y equals that they gave me pointing up, or it might be above the y equals line pointing down. And it crosses at 2 points. Okay? So that's one solution. That's two solutions. One solution, let me tell you, and all I did was I put this in the calculator and I got these values. Same thing, I already did these to save us some time. -6, 9, -5, 4, -4, 1, -3, 0, -2, 1, -1, 4, 0, 9. Okay? Now with these points, again, I have my vertex, which is also my 0, and here's my y-intercept. Okay? Now, I'm going to go ahead and start plotting these points. I have -6, 9, -6, 9, -5, 4, -4, 1, -3, 0, -2, 0, -1, 4, and 0, 9. And there I can see the curve. Well, okay, that did not quite work out. The curve of my parabola right here. Okay. All right. Now, for this one, what I notice is when at y equals 0, which is my solution, I only have one solution to that equation. Only one solution. Okay. So my roots is -3, 0. So my root is negative 3, 0. I only have one root because that's the only place that it touches. So in this case, it either sits on the y equals line, or it hangs off the y equals line. And when I say the y equals, I mean whatever y value they gave me. It happens that for this one, they gave me those two y values, but they could have just as easily said, like this one says y equals negative 1. So in this case, I'm not looking at the x-axis, I'm looking at negative 1, which is one row below it. Okay? So for these, I'm looking at the x-axis. But this one here, I'm looking below the x-axis at x equals negative 1. So let's take a look at that one real quick. Negative 5, 11, negative 4, 6, negative 3, 3, negative 2, 2, negative 1, 3, 0, 6, and 1, 11. And by the way, this one had 1 point. Okay, now, when I look at this one, I'm going to go ahead and plot these points, negative 5, and we're just going to kind of guess. We're going to go just a tiny bit above. Negative 5, 11, negative 4, 6, negative 3, 3, negative 2, 2, negative 1, 3, okay, 0, 6, wait, okay, negative 1, 3, 0, 6, 1, 11. Sorry about that, boo-boo there. Okay. Now I see my I see my vertex here and my y-intercept here, but I don't ever get to 0, okay? I never reach 0 because it goes 11, 6, 3, 2, whoa, going back 3, 6, 11. It never reaches 0. So in this case, solutions, there are none. And I'm looking for solutions where it crosses this line here at y equals negative 1. But it doesn't even cross 0. It doesn't cross until y equals positive 2. So in this case, I'm going to be below my y equals pointing down, or above my y equals value pointing up. And I have 0 points there. All right. So at this point, we've talked about this. This is our review of graphing and tables. Okay. Now we're going to talk about factoring. Okay. So we use factoring when a quadratic equation is easily factored, when it's already factored, or when the constant term is 0. Okay. I'm going to do more examples with you tomorrow about this, but basically what we're going to do, in this case, what you will hopefully notice about these is that all of my factors, instead of being like before, they just looked like this. We factored them and they just looked like that. They didn't have any equal sign. It was just a trinomial. It was an expression. Well, now they're equal to something. So now, since they're equal to something, I can actually solve and figure out what that thing is. So we're going to start these off just like we do anything else, by factoring. The first thing, you always have to, so it must be equal to 0 first. So the first thing you do is you make sure that it's set equal to 0. So like, for example, there was a problem on yesterday's homework where it said, I think it said x squared plus 9 equals 81. We wouldn't be able to use factoring for this strategy. It might have been x squared minus 9. I think it was x squared minus 9 equals 81. We would have to move that 81. We would have to get it set equal to 0 before we could use factoring to solve this problem. Okay? So it has to be equal to 0 first. That's like the first rule. Okay? And it says that right here. It must be set equal to 0 before you can factor or solve. Okay? But I felt like that bears repeating because it's so important. Okay? So this one is set equal to 0. So I'm going to factor it like I would normally. First thing I do is I look for a GCF. There isn't one. So I'm going to put it in the box and start factoring it. Okay. A is 3, B is 13, C is negative 10. Okay. 3 times negative 10 is negative 30, and B is 13. So they have to multiply to negative 30 and add up to 13. Well, that's going to be 15 times negative 2. How do I know that? I just do. But if you need to, you can always make a table, okay? So 15 times negative 2 is negative 30. 15 plus negative 2 is 13. So those are the two factors I want. 15x goes here, and negative 2x goes here. Again, does it matter where it goes? No. I'm sorry. I'm going to erase this just because I don't have room, okay? But you would normally leave it there. Okay, now I'm going to start taking out my GCF. The GCF here is 3x minus 2. Up here it's x plus 5. So my factors are 3x minus 2 times x plus 5. Now, this is where it gets different. And this is the only thing that's different. Before, it wasn't set equal to anything. And now it is. So I keep it equal to 0. We have this thing called the zero product property. I'm going to take a quick little detour. We're going to talk about the zero product property. Okay, so what the zero product property says is it says that if you have two numbers, so let's say I have like x times y equals 0. All right, and I don't know what those two numbers represent. One of them has to be 0, but since I don't know which one, I have to kind of like see what it would be if either one of them was. Like, for example, let's say I had 3 times x equals 0. Well, then what does x have to be? X has to be 0. Well, what if I had x times 5 equals 0? Well, then x has to be 0. If I multiply anything by 0, anything that equals 0 means at least one of the terms had to be 0. So what I have to do is I have to assume that I have to see what would happen if x was 0, what would happen if y was 0. So let me show you what that's going to look like over here. I have two possibilities here, okay? It's possible that this whole term is 0, because if this whole term was 0, right, then this times this would equal 0, because anything times 0 equals 0, right? So if this one was 0, then I could solve then x would have to be 2/3. So let's see what would happen. 3 times 2/3 is 2. 2 minus 2 is 0. So then this one works out to be 0. 2/3 plus 5 is 5 and 2/3. 0 times 5 and 2/3 is 0. So 0 could be 2/3. All right? Now, likewise, if instead this term was 0, so like if this was 0, this times 0 is 0. So also, that whole term could be 0. All right? And then I subtract 5 from both sides to isolate my x. And I get x equals negative 5. Okay? All this means is that I have two possibilities. I have two x values that could make this statement true. If I substitute in, and let's just do it, okay? Okay, okay, if I look here and I do 3, oh, there's going to be a lot of parentheses. 3 times, let's look at the first one, 2/3 minus 2. Again, all I'm doing is substituting in for x, okay, times 2/3 plus 5, I get 0. Okay, let's try the other one. Let's do 3 times negative 5 minus 2 times negative 5 plus 5. I get, oh, whoopsie, sorry about that, I messed up. No. Oh, I see what I did wrong. I forgot to put the parentheses in the front. Sorry about that. Oopsie. Okay, now I get 0 for both of these, okay? So since I get 0 for both of these, that means both of these values are true, and both of these values make my equation true. So that means my two x values that make y 0 are 2/3 and negative 5. Okay? This works because of the zero product property. We will talk about this a lot tomorrow. Let's do another example, okay? Don't freak out. basically, again, what this means is I have two possible values that are going to make this statement true, that are going to make 3x plus 13x minus 10 equal to 0. One of them is 2/3, one of them is -5. Let's try another one. Let's look at this one. We're going to factor it. So if I factor this, I have a GCF, right? The GCF here is 2. So if I take out the GCF, I have 2 times x squared plus 6x plus 9. Okay? So when I factor that, x squared, 9, that's 3x and 3x, so that's x plus 3, x plus 3. So now I'm saying 0 equals 2 times x plus 3 times x plus 3. Okay? So each of these terms, I'm going to set up a statement as if each of these were true. Well, first of all, if I divide everything by 2, what happens to this? It disappears because 0 divided by 2 is still 0. So now I have x plus 3, x plus 3, right? So I have two potential things. This one could be 0 or this one could be 0, right? So I'm going to say x plus 3 equals 0 and x plus 3 equals 0. Well, what do you see there? Aren't they the same thing? Yeah. So if I subtract 3 from both sides, I get x equals -3. I subtract 3 from both sides, I get x equals -3. I have two solutions, but they're the same thing. So that means I actually only have one solution. And if we were to graph this, we have 2x squared plus 12x plus 18. We look at the graph. Whoopsie, we look at the graph. And we have one solution because look, at 0, this thing only touches in one place. So at that one point right there, boom, that's my one solution where it crosses in that one place. And we have two factors, x plus 3 and x plus 3, but they're the same thing. So it ends up working out. Does that make sense? I hope so. Y'all better be writing down questions. Okay, let's look at the last one. This one is going to have no real solution. So let's take a look. So if I try to, so I'm going to start, I don't see a GCF, it's set equal to 0, so I'm going to put it in the box. Okay, so I have x squared and 5. Okay, so A is 1, B is -4, C is 5. So I need them to multiply to 5, but add up to -4. Now when I make a table, I can do 1 times 5 and -1 times -5. There is no way that I can actually get, there are no terms, no factors of -5 that add up to -4. This cannot be factored. Okay, this cannot be factored. So, I can't find factors of 5 that add up to 4. And it's not factorable. So there are no real solutions at this time. Okay, now, right now, I can't find solutions for this. Later on, we're going to learn a different strategy that you might be able to use. But for now, there are no solutions. Okay, this might, just because we can't factor it doesn't mean it doesn't have solutions. It just means, and actually, again, if we put this one in our calculator, x squared minus 4x plus 5, this one actually has no real solutions. You can see that it never actually crosses 0. It is possible, though, later on that it's possible there may be some that we can't factor, but we can still actually get an answer for. So that's all I have for this. I really hope that you guys wrote down questions. It is really, really important that you understand how to do this. So come to me with questions tomorrow, and I'll see you then.